like in the first section. Remember me giving you the story about the guys in MIT that did the quarters and wrote the computer program with a algorithmically generated quarter based off a roll of quarters? Y'all remember me telling you that? Somebody say yes, because I did tell y'all that.
Jamaica said yes.
Okay. There's the roulette wheel. Now that is a test question right there. So you might want to write that one down. The roulette wheel, and this is the one that we did in class. I didn't know it was in here. A roulette wheel has 38 numbers, 18 black numbers, 18 red numbers, and the numbers 0 and 00 in green.
You said 18 black.
Oh, yeah.
18 black and 18 red. And the numbers 0 and 00. Assume that all possible outcomes, 38 numbers, have equal probabilities. What is the probability of getting a red number on a spin? Well, that would be 18 out of 40. Okay. Then 22 out of 40 would be the failure. If patrons in the casino, let's write that down.
Why is it 40? Because there's two.
How many slots are there?
38.
18 and 18 is 36 plus the 0, 00, right?
Okay, I thought it was 38 plus, okay, so it'd be 38. I thought it was 38 plus 2.
The other
My
one you did
bad.
in 120 was like that. You had to figure that out, though.
So we got We got 38 slots total. We got 18 plus 18. 18 are red, 18 are black, and 2 are green, which means not red and not black. So I'm going to mark through green, and I'm going to say not red and not black. Why did I do that? Because success and failure is in terms of what? Red and black. Good. So that means the total is 36 plus 2 is 38 slots. Now, what did the question ask, so I won't have to go back to it? Did it ask for red or black? Okay, so it asked for red. What is the probability of a red color being the winner? Which means that is the probability of success, which means 18 out of 38. Now, if the probability of red is success, then the probability of not red is what?
20 over 38.
Failure, which would be 20, whatever y'all come up with. What'd you say?
20 over 38.
20 over 38. Now that answers question A, but it also starts to answer question B, which they probably are going to ask for the odds against somewhere in this question. Now all of the Math 120 books that I've seen always asked you for even and odd, even numbers and not even numbers. But of course this book goes against all the 120 books and teaches you black and not black, or red and not red. So this question is a little bit different. Go back to the question. If patrons in casino spin the wheel 1,000 times, how many times should you expect a red number? Well, 1,000 times that percentage would be what you come up with. There it is. Theoretical probability of getting a red number on any spin is 18 out of 38. And then you take that 47.4% and multiply that by 100,000 times. So this is nothing like the question in the other Math 120 books.
47.
But we're going to go ahead and do it because I'm going to give you the questions that I give you on the test. So let's go for the odds against. Let me pull up the, there we go. Okay, so we're going to say this is A. Find the probability of red. B. Odds against. Now, why do we always want the odds against? Because the odds against is what drives the gambling ring. Okay? You can't have a gambling ring if you do odds in favor. The odds against is equal to the probability of failure over the probability of what? Success. And I tell y'all to leave everything as a fraction so that way you won't have to depend on the calculator. So that'll be 20 over 38 divided by 18 over 38, which multiplied by 38 over 18, which is equal to 20 to 18, or 10 to what? 10 to 9?
Oh, I can't stop sneezing.
Means you're allergic to this classroom.
It is.
You're allergic to math. That's a new one. You have math disorder allergies. That's another disorder that they can create. Disorders are to the pharmacy companies as holidays are to Hallmark.
So where did the 8.9 come from? I'm sorry.
Where did what?
The 10 and 9.
Reduce 20 to 18.
Okay.
Now, C, if I gave you a test question, would be if you bet $500 and you hit a red space, what would you take home? That would be 500 times what? 10 over 9. Remember us doing the recipe with the cookies? And you just multiply by the constant. Well, here you multiply by the constant, which is 10 over 9. Now take your calculator and take 1 and 1/9 and multiply it by 500, or 10/9 times 500. What do you get? Whatever you come up with, it's not much.
It's like $55. Right.
What does it come up with? 500 what?
55.
Even?
Yeah.
Okay.
It's got some points on it.
Okay, what is it? Point what?
5.
Okay, 5.6. So what do you take home? $55.56. Now, my question to you is, why aren't you taking anything good home, like $2,000 or $3,000? Uh-oh. Oh, I thought
The probability is high to get.
the probability is high, so therefore the odds against is what? Low. So I want you, huh?
You get a green slot, you bring some.
Let's see. Do the same thing with the green slot. And you're going to bet $500 for C. So go through and do the same problem and do it with a green slot. You hadn't seen Zach, Miss Meredith?
I have not. I don't know.
He sucks. I told him to go ahead and Skype in.
I didn't see him. I don't think he responded either.
Can you hear me?
Yes, what you need?
Oh, you
I
weren't
just-
saying anything.
Huh?
I hear nothing.
I
can't
hear you.
Okay, I can hear you now.
You alright. You on drugs.
He talks like that all the time.
What?
The lady in the computer lab's laughing at you.
I said I
Oh,
wish
that's
I
nothing unusual.
was. No, I'm not on drugs.
I get that. You know where that comes from? That comes from my cousin Vinny.
I love that movie.
I love it too. He goes, and I wore this ridiculous outfit for you.
Mm-mm.
Are you on drugs? No, I don't take drugs. I'm going to hold you in contempt. There's nothing unusual. I love my cousin Vinny. I've watched that movie like 500 times. If it didn't have Marissa Tomei in it, I wouldn't watch it the first time.
You sound like a George Costanza.
What?
Forget about it. Never mind.
Forget about it.
George Costanza loves Marissa Tomei. I remember
Who's
that.
George Costanza? Who is that?
Seinfeld.
That's why I
Don't
said
even
forget
know.
about it. If you didn't get it, just move on.
No, I don't. I never watched
Who says
Seinfeld. Don't
that?
care nothing about Seinfeld.
Hilarious.
Believe it or not, George isn't at home.
That's why people. That's why I'm totally opposite. If everybody watches Seinfeld, I will not watch Seinfeld. I'm just one of those people.
Well, you should know. I binge
Nobody
watched
says
Andy
that they don't
Griffith
know
this
who
weekend.
George Costanza is, Hubert.
Say again.
Nobody says that they don't know who George Costanza is. Nobody.
Well, I didn't know who that was. I still don't know who it is.
Okay.
Which
log
character
off,
is it?
Go home, watch Seinfeld.
No,
come
I
back.
will not. No. I'm not going to be forced to watch anything. If I want to watch Seinfeld, I'll watch it. But I'm not going to watch it because 99% of the population watches it. I'm not that type of person. I'm the opposite. That's why you don't see me with smokestacks on my truck and 15 motorcycles, and I can only ride one at one time. So y'all give up yet?
I did.
Yeah, good.
Not-
Giving up, that's a good thing.
It didn't come out right. I know that right.
You're a failure. That's why you should quit. This college thing is just a joke. All right, so we got 38 slots total. And how many are not? How many are green? Oh, 2. Y'all get that? That's not a problem. 2 out of what? 38. So not green, so put GREEN and put X through it, is 36 out of what? So green is success, so odds against is going to be 36 over 38 over 2 over 38. Multiplied by 38 over 2. Dang old 18 to 1. Now multiply that by 500.
Hold on, how you get 18 to 1?
I'm Hubert. Nice to meet you. What's 36 to 2?
Oh, yeah, dude.
You keep forgetting to reduce.
I did. I don't like to do it.
What's 18 times 500?
9,000.
Why do you take home $9,000 versus 55? Because the probability is 1 out of, what, 19?
Raise your sheet up.
Oh, yeah, yeah, yeah.
Sorry.
Up.
That's everything.
9,000.
9,000 is it.
9,000.
Yep. So that's why when you go to Vegas, you want to know the odds of what you're playing because you don't want to waste your what? Time. If you go into something and the probability is 0.97 that you're going to win, are you going to invest money in that? No. Because if you got a 0.97 chance of winning, you might get 15 cents to take home. That's how odds work. It works the opposite way. If it's easy to win, then you take home what? No money. If it's hard to win, or it's hard to decide who wins, that's when you take home what? Money. Thus the saying, nothing is what?
Free.
Nothing is free. Nothing is free. You're going to have to pay for it. And people say, well, if you win the lottery, well, think about what you just said. Winning the lottery. Okay? What is winning the lottery? Easy to win or hard to win? Well, it's hard to win. And in this case, if you put it in respect to this marble rolling around this roulette wheel, it's about hard to win to the 15th power. So yes, you can be set for the rest of your life. And if you go to my Facebook this morning, I did one of those things that you do for fun. And it says that I'm going to win the lottery and I'm going to be a billionaire. Okay, of course, I laugh at it because that's a joke. It's a fun thing to do. It's a joke. I'm not going to put all of my eggs in one basket saying that I'm winning the lottery. I'm not going to do that. I got into a discussion with a friend of mine. I only got one or two. And we talked about what?
Oh, no.
Yeah. My grandfather always said if you can count the number of friends you trust with your money and your family on your hand before you die, you're doing all right. And I've got two. So, anyway, to make a long story short, we got into this discussion about if you believe in God. Okay, everybody with me? Do you believe in fortune telling and ghosts and all this other stuff? And I said, no, you don't. I don't believe you can believe in both. And we got into this big discussion. And this person is supposed to be a devout person of faith, but they go to a psychic. And I'm trying to figure that out. Why, if you believe with all your heart in this entity, why do you go to a psychic? Yeah, you're right. And their reasoning, this is their reasoning. Their reasoning is God uses psychics. And I really had to go back to my Sunday school classes because I could not figure that statement out. I'm anti-psychic, okay? I'm anti-psychic, anybody that comes in here and tells you that if somebody was to walk into this room right now and say, Hubert, I can tell your future. First thing I would say is, give me the 5 lottery numbers plus the Powerball. Unless you can do that, walk out of the freaking room. Get out of here.
Don't lie. You know you called Miss Cleo.
Yeah. Yeah, I called her and wondered if I was ever going to find true love. Yeah, I sure did. She was a fraud. Anyway, I just think some people are kind of mixed up. I really do. And that's just my own personal opinion. Okay, so speaking of the lottery, there are 2 types, and I'm going to go ahead and get into the counting section because I'm covering 3 sections that are on your test. Let me go ahead and write them down. 1, intro to probability. Intro to probability includes basic probability and odds against, odds in favor. 2, the additive and multiplicative rule. The additive rule, always subtract the overlap. Mm-hmm. The multiplicative rule, always remember with or without what? Replacement. And when does with or without replacement don't matter? After, I say 300. It doesn't matter. Now we're going into counting. Now everybody in here knows how to count. All right? When they say counting, they're worried about that guy. Was that my voice?
Say what?
Nothing. I don't want to confuse you, Meredith. It sounded like my voice. What do you call it? Feedback? Okay, forget it. All right, counting. What is that number? What is that exclamation point in math called? Factorial. It's called factorial. Factorial is when you multiply the numbers in sequence down to 1. So what would 6 factorial be?
You mean like a number tree thing? Like a factor tree?
Just multiply it in sequence. 6 times 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. On your calculator, it should be under your math, probability, and go down and it should have factorial. So if you want to do 6 factorial and 7 factorial, you can do that on your calculator. Let me pull up the handy dandy calculator. There it is, TI-83. And I'm going to say 7, math, go over to probability, go down to factorial, hit enter, and enter. 5,040. Now I'm going to do 6 factorial. Watch this. This is a trick I learned during the war. Hit second entry and change that 7 to a 6. And hit enter. 720. Now, factorial. When do you use factorial? You use factorial when you're dealing with combinations and permutations. Combinations, no order, permutations, order. Now, in the section that goes over counting, and I have no idea what section that is, I would assume it's 7C, whatever the third section is in your outline that I gave you and y'all don't look at. It's going to say counting. There's going to be a couple in there, like if I gave you the word smile, how many different combinations of those letters can you generate? Well, 1, 2, 3, 4, 5. That'd be 5 factorial, which would be 120. So there's 120 different combinations of SMILE that you can make. Now, do they all mean something? No, they don't mean anything. When should you be able to do that? Some of y'all have an ATD alarm at home. Yes, maybe?
Yeah.
Okay. How many numbers are in your code? 4? Okay. So think of 1 through how many numbers are there? There's infinite one. There's 10 numbers. Does yours use numbers or numbers? So 1 through 0, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So that's how many numbers? That's 10 numbers. So can you repeat? You can. So you can repeat. So that would be 10 factorial or 4 factorial well, combination, you'd have to do 10 to combination 4, because that's a combination using two different things. You got 10 numbers, but you got 4 spaces that you can use those numbers in. So how many different combinations does she have? Well, take your handy dandy calculator, and that would be a combination. That would be 10, and then you go to math, probability, see that C? 4. She's got 10 numbers to choose from. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. That's 10 numbers. She's got 4 slots to put them in. So how many different combinations does she have? 210 different combinations. Now all you have to do to figure out how to get in her house is write an algorithm to go through those 210 combinations. And eventually it'll take maybe 15 seconds to get into her house if you've got an algorithm that generates 210, and you would use Factorial in your programming to do that. Y'all ever seen Terminator 2?
Ghana, if you want to live.
Do you remember when he takes the card and puts it through the ATM machine, and that computer takes all those numbers and crunches them down to an ATM number or a security code? Yes, I remember that, Hubert. Well, that's what I'm talking about. Everybody's so talkative this morning. People I want to talk. People I don't want to talk all the time.
Ha ha.
Ha ha. Not talking about you. All right. Be quiet. Be quiet, Melanie. Don't say anything.
She got her thing muted anyway.
I have to lean all the way over and mash this mute button.
What's the matter with you? What are you having to look through? A sliding projector or what?
No, I'm extremely lost on this chapter, Hubert. So
Where are you lost?
Are you serious? Is this real?
Okay, tell me where you lost.
So in this number 2, where the subtraction of the overlap.
That's when we use the highlighters.
Okay. So anything that's over 300.
Okay, we'll go over that right quick. Remember, when I told you about the additive rule, I told you that most of the time it would be a table. Okay? I said, remember me telling you don't read into the table too much because it'll confuse you? So I'm going to give you a table. 18 to 35. Responded. Did not respond. Let's say we sent out a survey. And 36 to 40. Or 36 to 49. There we go. And this is 4, 6, 3, and 2. All right, this is what's given on an additive rule. Hand me your highlighters, because you have highlighters. And I forget I don't have highlighters. Remember me using highlighters that day? Yeah, I remember. Okay.
Yes, I remember that.
Okay, well, that's the additive rule. So if I ask, here's what the question's going to ask you. I want the probability, and what's the word that goes with the additive rule? Or and? Or. Of responded or 36 to 49. So you highlight the responded, and you highlight 36 to 49. And now you write down all the numbers. Now the total is what? 15? And then the blue, that's responded. And the yellow, you're going to add those two together because that's the additive law, and then you're going to subtract the what? Overlap.
Okay. Well, I understand that.
Okay, so the statement you made a while ago, I don't understand this chapter, is incorrect,
So it's 7.
right? I want you to
Fine.
say that statement was incorrect.
We just need one.
Statement
page.
is incorrect, Hubert.
Okay, thank you. 4 plus 3, and then 3 plus 2, and then what's the overlap? 3 is the overlap. Now what's 4 plus 3? 7. 3 plus 2 is 5. 7 plus 5 is 12, minus 3 is what? 9 over 15, which is 3 over what? 5, which is 0.6. All right, I'm going to give y'all one to do by yourself. If you can't do it, what does that mean?
We suck.
There you go. So P of responded period. Do you subtract an overlap on this one?
Is the overlap on this one?
I said, do you?
No.
No, why? You said
you don't overlap.
you don't overlap. It's just the blue. So if there's no overlap, you don't have to what? Worry about it. 4 plus 3 over 15. 7 over 15. Which would be 30, 14 divided by 10. Divided by 3 would be over 10. 3 into 14 would be 4.6, be 0.46.
So we can go ahead and divide it out.
Yeah, what's 7 divided by 15? Did you check it? It is 0.46. God, I'm amazing.
You is. Lord.
All I did was change this into tenths. And this came out to be 4.6. And when you take 4.6 and divide it by 10, it becomes 0.46. Okay, now that's the additive rule. Now, I'll tell you this, Melanie. You know when students have the roughest problem with these questions? This.
When I don't have the availability to say ask my instructor or view an example, that's when I have the roughest.
Well, that's because this book is stupid and we should not use this book. But do you know why they want us to use this book? Because the Clemson professor wrote it.
Oh, is that right?
Yeah.
Well.
Anyway.
I thought it was so they could sell us some new books so they could make more money.
No. The only reason we use this book is because the professor wrote it at Clemson, and I used to teach with her, and she was a terrible teacher, so that's why it's a terrible book. Anyway, this right here is not given. Sometimes you have to create what? You have to create the table. And that's why I don't like this book, again, because most of the time in the 120 book, they'll give you the table. And I tried to pick homework questions that gave you the table. I don't know if there's questions in there that gives you the table, but I tried to pick the ones that did. And that's the additive rule. Multiplicative rule, I gave you, in the multiplicative rule, I gave you the marble question, and then we did the CDs. And the CD question, I'll go over it. You got a case of CDs, and in that, or a pallet of CDs, and in that pallet you've got 5,420 CDs.
Same question.
Same question as we did. I don't think I picked the same numbers. That would be almost. Wow. And quality assurance says that 1,000 of these CDs are probably bad. But to test it, we're going to pick 5 CDs out of the box, and if all 5 are bad, then we're going to send the box back to be melted down and start over. Okay? Because if all 5 CDs are bad, that means that at least 1,000 are bad, and that's unacceptable. Okay? So, 1,000 are bad. So how many are good?
4,420.
Which we don't really care about that because that's not what we're concerned with. We're concerned about the bad ones. Now, this is without replacement. Now, why would this be without replacement?
You're not going to put bad ones back.
You're not going to put the bad ones back. In other words, you're not going to put one back in. So these are always without replacement. Does it matter?
Yeah.
With this one?
No, it don't matter.
Don't matter with this one because it's over 300. So it doesn't matter. But we're going to do both just so you can see it doesn't matter. So I'm going to do 5 draws. And the first one is going to be 1,000 over 5,420. The next one is going to be 9,999. Oops, just 999 over 5,419. 998 over 5,418. 997 over 5,417. 996 over 5,416. Now I want somebody with a calculator to do that operation. Who's going to volunteer? You going to do that one? Miss Robinson, you going to do it?
Somebody else need to do it.
Well, y'all two do it since y'all got your calculators out.
We just house them together, right?
Yeah, but do them separately and write them down so you'll have everything written down in case there's a mistake. Melanie and Meredith, I want y'all to do 1,000 over 5,420 raised to the 5th power. This is without replacement or with replacement. Which you're not supposed to do, but since it's over 300, it really doesn't matter. And I'll do that one with you on the calculator here. So I'm going to take my handy dandy calculator and I'm going to take parentheses.
Oh, I'm getting 180.
Hold on. 1,000 divided by 5,420. And I'm going to raise that to the 5th power. You should get around 0.0002, something like that. I get 2.137979651 times 10 to the negative 4th power. So that's 2.137979651. And then I'm going to move 1, 2, 3, 4. I get 0.000214.
I got 214.
0.000214.
40214.
Should be 3 zeros. Now, what did y'all get when y'all did without replacement or with replacement? What'd you get?
2.119 exponent shenanigans, all that stuff.
Okay, 2.119 times 10 to the what?
-4.
-4, which is 2.119, 1, 2, 3, 4, which is
There was a bunch of numbers.
0.00021.
That's what I got.
What's this? 0.0002 what? 1.
That's what I got.
You're not going to get a big difference between 5 decimal points. So, in this case, Melanie, which method can you use? You can use either. Now, which one should you use? This one, because this one saves what?
Time.
Time on the test. But you can't use that all the time unless you have 300 or more. Now, you can try it with around 200, but most of the time, the rounding is not going to come out to be what you want it to be. Capiche?
Capiche.
Okay. Now that's the multiplicative and the additive rule. Now, back to this. Now, remember this question right here, the smile? Because there's going to be a couple of questions on homework, and it's just a basic 5 factorial, 6 factorial. This is just an introductory factorial question. I won't test you on it very much. What I'm going to test you on are these two. Okay? Now, I want to go ahead and get through this section because all I want to do for the next 2 days, Wednesday and Monday, is go over homework. Okay? Because this test is going to be short and sweet. It's going to be 3 sections, and that's it. So, combinations. Remember, no order. Combinations means no order. So, let's go to our handy dandy internet. And let's pull up what I play every Monday and Wednesday, the lottery. And when I say I play it, I don't play it like some of these goofballs out here. I buy 5 tickets. That's $10. Okay? And I look at it as giving money to some people that don't.
Lottery tuition.
Exactly, lottery tuition. That's what I do. So I pull up the www.southcarolinalottery.com. I think you have to spell it out.
Oh, no.
Nope. And go down here, the Players Club. What? Mm-hmm. Yeah, I'm a player. That's not the right one. There it is. There's South Carolina Lottery. And you hit Powerball. How to play. Now, I want you to write. I'm going to blow it up for you. Can I? Well, I'm just going to blow it up. There. All right, write number 1 down. You don't have to write it word for word, but you need to write it down because you're going to see it on a test. Select 5 different numbers, the white ones, from 1 to 69. And select the Powerball 1 to 26. You don't have to write down the second part. Just write down that first part. select 5 different numbers from 1 to 69, and the red ball, which is the Powerball, from 1 to 26. Does it say anything about order?
Nope.
No. So therefore, this is a combination. The actual question will say something about order, or have first, second, third place, or it will say something about president, vice president, secretary, and treasurer. If they want something about order, it will specify. If it doesn't say anything about order whatsoever, then it's a combination. Now, in order to win the lottery, you have to what? Play. So that means you assume at least buy 1 ticket. Okay? Now this is a big thing with the homework and the test. If it asks you what is your probability of winning, it assumes that you're buying at least what? And if you don't put that 1 up there, guess what? You get it wrong. So I'm just going to go ahead and tell you that right now. If you don't buy at least 1 ticket and you don't put that 1 in the denominator, then you're going to whine and cry because you got it wrong. Now, there's 2 things you have to multiply down here. There's 2 combinations. The combination of the white balls and the combination of the red Powerball. And the combination, there'll be big C's, because it's not a permutation. N is always your biggest number. So let's go back to the white balls. The white balls are 0 to what? Or 1 to what?
69.
Okay, so that's 69, right? So that'd be 69 combination 5. Because how many white balls are there? How many slots? There's 5 white ball slots. What's the Powerball? 1 to what?
26.
26. So that'd be 26 combination. How many Powerballs are there? 1. So there's only 1 Powerball and there's 5 white balls. Now, 1 over, and then we do this math in our calculator.
Figure out how to do it in mine.
So you take your calculator. Let me pull out the calculator. I think I closed mine out. There we go. And I'm going to go ahead and do the bottom first. 69 combination 5. So I'm going to go to 69, math, probability, combination, 5. Enter.
Is it NCR's combination?
Mm-hmm.
Oh.
And I'm going to stow that. I'm going to say alpha F for what? The first number. Okay, now I'm going to hit second, enter, second, enter. And now I'm going to change my numbers from 26 to 1. It's going to be 26. And I'm going to stow that. Alpha S for the second number. So, go back to my handy dandy white page. And that's going to be 1 over, I forgot the number, 11,238,513 times 26. So in my calculator, I'm going to do 1 divided by parentheses alpha F for the first number times alpha S. Oops. Hold on. Alpha S. There we go. Close parentheses, and I'm going to put another parenthesis right there because I got to differentiate the denominator from the numerator. And I get that number right there, which is 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And 3, 4. Now, if you want that in fraction form, it would be 1 over, and then we just multiply alpha F times alpha S. 292,201,338. Now, who's smarter? A person buying 1 lottery ticket or 1,000,000 lottery tickets? Bless you. Well, we all read to the second decimal place, do we not? What do I mean? Well, when you go to the store, do you take your cents to the third decimal place, or do you just round it to the second decimal place? To the second. You don't say 0.395 cent, do you? You say 40 cent, don't you? So this is 0% with 1 ticket. Everybody understand that? We have 0 probability of winning the lottery with 1 ticket. Well, what if you have 1,000,000 tickets? So change this to 1,000,000 tickets. So that would be 1,000,000 over 292,201,338. Somebody tell me what that answer is. Well, I'll do it on the calculator. There's the answer right there. So that'd be 1,000,000 divided by inverse second answer. Enter. Who's smarter? Person that buys 1 ticket or the person that buys 1,000,000 tickets?
1.
1. Because what's the probability? The probability is still the same. Now a lot of people say, well, that's really not right. That's 0.003 and that's 0.000. Not by practicality standpoint. From a practicality standpoint, you're at 0%. Both are at 0%. And I've got a black dot on my finger. Okay? Now, what's the difference between permutations and combinations? A permutation question will be like this. There are 40 members of a club. They decide to elect officers. President, Vice President, Secretary, and Treasurer. Treasurer is one of those offices that are being done away with. Does anybody know why?
Embezzlement.
Embezzlement's one. The other is people don't want other people to know what people are given. So how do they keep up with it? I don't know. So this would be a permutation. Why? Because this represents what? So this would be 40 permutation of 4. And you would punch that in your calculator. Now, what if I said a 5-member committee? Does a committee have offices? No. So this would be a what? A combination. 40 combination of 5. And you would punch that in your calculator. So you'd go to your handy dandy calculator and you would type in 40 math, probability, NPR, and 4. 2,193,000 360 permutations. So in other words, if you took all the people in that 40 member group and you said Buffy, Jane, Mike, and Bob, then the next one would be Buffy, Mike, Bob,
Shaniqua.
whatever. All them different combinations, there's going to be over 2 million combinations. But what if you just did a 5-member committee? Well, that would be second combination, second. I'm just trying to find it. Oh well. There we go. Be 40 combination of 5. Why is that less? Why is this less than this?
Because it doesn't variate for position.
It don't have the positions. See, once you do one level of committee members, then you have to go through and do a level of order. And that's why this number is so much bigger than this number. Because you have to add that extra layer of order. So your permutations will always be larger than what? Permutations will always be larger than the what? Because of the extra layer of combinations you put in that's in reference to the order. I have to keep checking my phone. I got to pick up my son today and I got to... Nope, still waiting. Question. Great. Complaint. Somebody looked in your book and told me what section the counting is. I think it's, yeah, it is. It's this section. Let's look and see. I think it's the section I turned to. That's what made me. Well, right now I can't even get to it.
Counting and probability 7E.
Okay, 7E.
And then 7 delta was assessing risk.
Hold on one second. 7, yeah, 7B, 7D, no. Law of large numbers, I've already told you about that. Counting and probability. So you're responsible for this test, 7A, 7B, and 7E. And today, Wednesday and Monday, we will be working on homework questions. So make sure you start sending them in, because after Monday, we're going to go ahead and do the test on Unit 2. So I'm giving you 2 days to send in questions, which would be Wednesday and Monday. I should see questions Wednesday. Now, Miss Smith, she's not here today. She sent a couple of questions, and we'll go over those Wednesday. Well, Wednesday when hopefully she'll be here. I'm not going to go over them until she's here. Who else got questions?
Oh, God.
All right. Well, hopefully the Easley campus will not flow away in piss and urine, and hopefully y'all will be up there Wednesday. Maybe they'll call in those people that's got the green shirts on. You know, those people that act like nothing ever happened. You ever seen those commercials? So let me ask y'all. So what do you think about the psychic thing? You think psychics and people that see ghosts, and you think that's real?
Nope.
I don't think psychics are real. I don't know about ghosts. I don't know.
I ain't never seen no ghosts, so I don't think they're real.
I think as the person of my faith, I believe that demons are real,
Yeah, I do believe
and I believe that demons masquerade themselves as dead people and ghosts. I believe that. But I don't believe that my father is going to come down here and tell me what I need to do for this or that or this or that, because my father don't want to come down here after where he's at now. He don't want to come down here. So
Say that I don't believe in any of it, but when I was a young woman, we saw, this voodoo lady that said she spoke to dead people, and that was in the city of New Orleans, which is very rich in that kind of hogwash.
oh yeah.
But she told me about my grandfather who died when I was 11, and Hubert, she said things that there's just no way
Yeah.
that she would have.
I agree 100% with that, but you know what that is, though?
But how
In
did
my
she
opinion,
find-
that's the demon. I think demons can do that. I don't think it's your grandmother or your grandfather telling her that. You know what I'm saying?
Yes, but I get what you're saying, and she was a very demonic person, so I'm sure there's something to that. She really was. These voodoo queens are scary, and there's something to that. But she said things about being in a garden, and when I was a little girl, we grew tomatoes, and she said tomatoes and okra, and those are things that there's just no way that she, my grandmother wasn't even with me, so it's not like she was telling her secrets. It was very surreal,
Well, I have no doubts that she said that, and that there was a demon that said that, because you know as well as I do, there's demons and there's angels, and demons can. You ever seen? I watch a lot of horror movies, and in all the horror movies, you know what the guy that's fixing to do the Exorcist, you know what he says? He says, "Now, you be careful. Don't listen to the demon, because the demon will tell you things that you what? You want to hear."
Want to hear, right?
Yeah, and the demon will tell you things that only you know.
Hello.
And I agree with that 100%. I just don't think you can mix the two. I don't think you can. I don't think you can sit there and say, I love Allah and I love God and I love Jesus or I love Buddha, and then say, oh, but I'm going to put this on hold and I'm going to go over here and talk to the psychic woman. I don't think you can do that.
Okay, people that people that go to jail, they be discovering other people's religions and stuff, then they change their mind. What they call them people, they ain't got really no religion. You get what I'm saying?
Non-denominational.